Hello, and thank you for joining this session on the refinery of the future. I'm going to walk you through some of the activity trends in the market now, some of the most recent occurrences and events, the current technology trends that we see as we have from last decade to current decade and into the future, and Honeywell's activity to take up the challenge of improving operations on an ongoing basis for refiners. This is the set of topics that we're going to cover in the presentation, initially about refining and business changes, and we'll talk about petrochemical integration. We'll talk about technology evolution and how that impacts how things are now possible to be done now and into the future with refineries. And then look at the refinery management and its characteristics of capability and performance, as now affected positively by focusing on flexible operations and connectedness in the refinery. In refining these days, of course, there's been a very large impact. It is the overriding impact in the current time frame from COVID-19. A very large number of refineries, a significant number of refineries, let's say 20 and more, have been shut down or documented to have shut down from what market analysts tell us. The return to product demands will not be as fast on the way back up as the demand collapse was during the national lockdowns that occurred during the beginning of Q2, let's say for most people, end of Q1 and beginning of Q2, March, April, May. But jet fuel demand, recovery of jet fuel demand will be slowest, with a slow uptake and recovery of flying globally by people for both business and pleasure. In the meantime, crude feedstock prices themselves have collapsed. I'm sure everyone in the news has seen the price collapses. We're down to the $20 to $30 range for an extended period of time. The overhang of capacity, of oil production capacity globally, that is production capacity much higher than ongoing demand, is going to be around for a while. And therefore the politics of oil production are going to dictate some of the pricing levels that we see. But there's no expectation of an immediate recovery to anything like the pre-recovery numbers around the $50, $60 a barrel. In general, we talk about peak oil demand rather than peak oil supply. Back in 2008, some of you may remember, with the price peaking at over $140 a barrel, there was very high growth in Asia at the time. And since then, economies have cooled, and we're much more talking in terms of what analysts tell us about reaching global peak capacity, peak demand in oil in around 2035, more or less, as energy efficiency in economies grows and the oil sources other than energy sources other than oil and other than gas come into play as well. There have been some market disruptions from the ultra-low sulfur fuel oil MARPOL regulations since January 1st this year, but oddly enough, because of the much larger impact from COVID-19, the impact has been muted or kind of difficult to see amongst the detail of the large-scale COVID-19 impact. So we see low sulfur specs globally in fuels, India, China, everywhere. We see retail car diesel in disfavor in Europe, which means that overall the demand for diesel within Europe is likely to be capped and likely to trend down in a relative sense. Many smaller refineries have closed globally over a number of years, and now due to COVID-19, those less efficient refineries may have a more difficult time coming back up. There's more integration to chemicals. We see investments still ongoing now. I guess those pre-committed to COVID-19, though some may see some delays now. There's some in Saudi Arabia, some in India, some in the US, and of course some in China, where large-scale petrochemical projects are being put on as add-ons or as joint common investments with new refinery sites as for ZPC in China, for example, in the current time frame. We also see a trend towards consolidating control rooms. Many sites that have grown organically over the years and added control rooms as they added processing units. We see a trend towards reconsolidating and gaining efficiencies from those investments. And we see, of course, in oil in the North America, with the production of shale oil being lighter, that has an impact on refining configurations and on export potential for American products. Again, that last line being overridden certainly from the recent developments for foreseeable future in COVID-19 with large-scale product overhang in the market. The initial view of Refinery of the future can be seen on various different lines as shown here. The initial state for most sites in the world and historically has been a standalone crude oil refinery with perhaps a separate operation by another company over the fence, sometimes by the same company, but operated with a completely separate set of objectives on the petrochemical side compared to the fuels focus of the main refinery. Sometimes with the energy consumption being shared and energy planning being done together, but largely operated as separate operations, as you see near the top here, with the refinery on the one side, on the top left, and the petrochemical side in the top right. In a more recent scenario, we've seen more petrochemical integration within refinery operations, with more focus on petrochemical production, and the yield pattern shifting towards petrochemicals from fuels for some operations. And that has been an ongoing focus for a number of different sites. And we've seen investments in this way, not just in the Middle East, but in the US and, of course, in the Far East. The more recent approach is actually consciously in the bottom line here on the slide, is to focus on taking crude directly to petrochemicals, with the fuels operation being very much the secondary operation within the planned investment, and the focus on petrochemical markets and petrochemical operations being the key to the investment business case. The addition of petrochemicals capabilities to have a positive impact on the yield pattern and the profitability and market focus of a refinery can be done in a number of different ways in different scenarios as fits a refinery's current situation. Examples here include maybe at the bottom end from vacuum bottoms, adding a heavy feed hydrocracker such as a UOP Uniflex to produce mid-distillates that can then be used in the distillate hydrotreater or FCC, or add a hydrocracker directly on middle distillates to improve quality, but also provide some extra naphtha for naphtha complex. And then from the naphtha complex, adding aromatics conversion capability to focus on production of paraxylene maybe as a precursor for an external polyester plant to use as feeds. And on the top end, to look at use of the LPG coming from the crude units, but also maybe from the FCC units to provide feed for steam cracking to produce ethylene or propylene, and any propane to be used in a propane dehydrogenation unit such as UOP Oleflex to maximize production of on-purpose propylene, while producing hydrogen for other units such as the hydrocrackers and so on. So for the refinery of the future, we've talked so far about the integration with petrochemicals and how investments can be focused to change the yield pattern and change the financial fortunes of a given site. But really the key trends that I want to focus on for the remaining time we have is to talk about refining as a flexible operation and the connected refinery, being able to apply technologies to maximize the ability of the refinery to react to changing market conditions, to changing conditions inside the refinery, as process units perhaps have performance issues, and still be able to react in the best way possible. both the flexibility and the connectedness of the refinery are the end point or the results of ongoing technology developments from the prior decades, from this decade, and ongoing into the future, including, for example, in the top box, the use of virtualization, as Honeywell was the first to virtualize a control system, the use of virtual engineering platform, VEP, to provide a very flexible remote community for engineering automation projects to end users, to engineering contractors, to licensors. The use of Experian Elevate for remote distributed assets, largely for oil and gas and remote energy assets and so on, not as much in refining, but also the overall digitization of projects, the ability to keep track of automation information through projects and hand off to engineering and to operations for consistency, and that's auto documentation capabilities such as in Trace, for example. The use of smart engineering tools to provide allow refiners to buy, for example, control capacity rather than buy individual controllers, as you can hear in the Experian Hive sessions in VTECH 2020. And lastly, in this particular bullet point, to look at Experian solution suites for UOP units. These are pre-set up, highly rich starting point for engineering of database, of graphics, of alarms and control applications for specific UOP units, such as CCR reformers, platformer for Appendix ISOM units, and many other units that UOP provides as well. The use of smart I/O, really smart protocols of I/O, channel electronic of individual channels that does not depend on the signal type, whether it's AI, AO, DI, or DO, landing on the same physical connection, and providing the smart or soft configuration of those purely, as well as providing smart conditioning and barriers. And remote I/O are all trends that are now being taken up in the industry, providing much lower cost base to the end user of smaller building space, and so on. And this based on the emergence of smart I/O protocols, the much more prevalence these days of HART as a smart device or intelligent device protocol, providing flexibility and usability over top of universal I/O, for example, and much less use of foundation field bus, we have to say, in recent years, from being a much more, I would say, fixed engineering and management of change intensive kind of protocol. And the market has moved largely away from foundation field bus in general. The emergence of Ethernet-based protocols, EIP, Profinets, advanced physical layer, all provide for future plug-and-play capability for individual I/O channels and self-configuration. We can see and anticipate more developments in general, I think, in this direction, as well as some more edge devices connected straight to the cloud. We have certainly conversation with customers on the ability to connect signals that are not for control, not for safety, not for management in any sense in real time, but simply available to provide information to higher level users that go largely through a wireless data capture into a cloud instance of real-time data. The use of smart commissioning has emerged, providing the ability, using the capability of smart devices themselves to self-configure, and from the control system to interrogate those devices, and the control system to then itself verify its own configuration and provide documentation, reducing the amount of efforts and the amount of time for engineers to verify individual loops, has been transformative in a number of key projects. The emergence also of using fundamental principal models for digital twins, as I call it, process and asset surveillance. So we're getting rid of private spreadsheets with a private structure into shared views, shared models of performance of pumps and compressors and filters and distillation towers and reactors, all based on updated physical principles. Those also complemented where necessary using artificial intelligence, using data-driven machine learning models as well. And lastly, a very significant focus on the full life cycle of process safety in recent years, from linkage through full data linkage from the HAZOP to LOPA to safety requirement spec to implementation, and then to online real-time capture of actual shutdown performance versus advertised capability and failure rate assumptions and so on. These have been the key elements overall of technology evolutions, if you want, that have driven where we can foresee a much more flexibility and connectedness for refineries. In the bottom box, I show some individual, more general technology trends that I think we have seen in many cases. The use of non-Microsoft user interface devices such as smartphones, whether Android or iPhone or Windows-based small devices in the field. The use of much more wireless in the plants. The emergence of 4G, and of course the ongoing evolution of 5G in many markets, and possible use in plants for that as well. Much more distributed safety-related applications, as you see here in the middle, with logic solvers certainly being able to put out in the field, close to operations, small scale safety applications are much more effective to put in place than they were before. And then the tracking of individual performance, individual behavior, individual work in the plants through use of personal gas detection, real-time location system, permit to work, and providing really the foundation for overall real-time operational risk management. These form the compendium, if you want, of all the technologies that have an impact on current trends. So with our objective of having a connected and flexible refinery, there are at the core a number of operational objectives that we need to keep in mind. That begins inside the gates, operating safely, of course, under all conditions, being able to maximize net cash margins as a financial objective, but at the same time, while maintaining run length, since refinery units run for a certain number of years before requiring major maintenance, and the longer those run lengths are, the better the financial performance. But at the same time, maintaining quality products and not having product quality giveaway, making just enough quality to be on spec, but not more, while eliminating and minimizing unplanned downtime. Since refineries are very high fixed cost operations, keeping the place running is key to ensuring a good performance. And as well, planning and managing the capability of the refinery and sustainability over the long term is important, in the sense that it is not productive to do something that would be beneficial in short term for only a short period of time, if at the same time it is at the expense of later processing difficulties in the refinery. So managing the ability to achieve the predicted run length is a key part of the activity as well. Outside the gates, some refineries also operate their own terminals and sometimes manage their own bulk transports, and some companies manage their own retail transports as well. All of those different operations need to be coordinated with the refinery operation. And if there's, of course, as we've talked until now about petrochemical integration, then there's the attention to all the logistics for loading and unloading petrochemical products into different kinds of tankers, different kinds of rail cars, and so on as well. So taking all these together, the idea is to find a way to manage the capability and infrastructure of the refinery. On the one hand, manage the base asset as it is, keeping everything safe and running. On the other hand, to manage the performance of the refinery to make sure that we can make our money back and be a sustainable business. So as we examine a little bit more what it means to achieve flexibility and connectedness in a refinery, we've come to a conclusion that we need to manage the refinery capability, the base assets that we have in a safe way, consistent way, as well as to manage the performance of the overall assets in order to achieve our financial results. For Honeywell Process Solutions, what this means is managing a number of different cost elements that come into play. The crude, when you can say, has already been purchased, has already been delivered, as we see in the left-hand box, and we begin to take it in and process the crude oil, and then we start to transform the crude oil in the middle box and achieve higher value products at the expense of energy, at the expense of people and maintenance and equipment and so on. And these are the operating expenses in the third box, in the fourth box on the right. And then from that, we achieve a net cash margin. So attention to all the different cost elements within an existing refinery become key to achieving performance. So we can tie in this idea of managing capability and performance of a refinery together onto a layered automation map as traditionally done, and see that there's a significant amount of overlap between managing the capability, the main assets, and base safety and consistency of the site, together with its performance and its return for investors. And that means that there's requirements for good capability, literally in managing systems at the core level, but also refining knowledge and ability to understand how a refinery operates in order to really achieve the performance objective. And these tie together, if you see, into our earlier stated concepts of flexibility and connectedness. So the connectedness itself is required, but the refining knowledge complements that in order to achieve final results for refineries. This overlap of capability and performance requirements to be in best position to manage refineries is what has been so productively implemented in the Experian PKS platform, bringing together elements that you see across the bottom as regards to capability, and elements roughly around the top line related to performance. And we'll go through some of those in a little bit of detail now. On the bottom left, the process control and process safety, of course, for many years, a core integral part of the Experian PKS platform. And also now, for many cases, implementation of such elements as catalyst recirculation, dryer recirculation, such as for UOP units, implemented directly in the controllers and integrate and maintained and managed in the same platform as well. Integration of third-party packages as may be required for package from OEMs. As well as loading activity in terminals, as well as integrating of fire and gas devices for both buildings and for process areas into safety-related applications. The integration of CCTV cameras into Digital Video Manager as an integral part of Experian PKS has been used for many years by many customers, including for video that watches process areas, watches flares, and even from portable cameras watching maintenance operations for temporary purposes. The integration of the wireless environment has been very, very well done into Experian platform for use of any individual signals coming in or to manage productive work going on in the site and provide the overall networking infrastructure as people walk around the site. Integration of perimeter protection and overall security has been for many years available in Experian PKS as well, along with the measurement of tank levels and tank gauging directly into Experian, into either same or separate instance of a system that can be used to manage tank farms, manage terminals, and so on. the measurement level. And lastly, on the bottom here, the ability to perform turbo machinery controls in the native C300's 20 millisecond capability that we have now for turbines, compressors, and major rotating machinery in general. And roughly across the top, we see elements related to performance aspects in the refinery, beginning with the UOP pre-engineered solutions that I mentioned before, a pre-engineered database and graphics and alarms and operating instructions, but also of process models that can be available for monitoring and use here in the top middle for advanced process control and optimization of these units. We can optimize, for example, a combined CCR platform or reformer with an isomerization unit and a hydrotreater on the front end. The same kind of performance capability applies to connected worker, equipping workers with smart wearables, intelligent wearables in the plant so that video and voice are captured directly to the experience system for a very rich kind of collaboration capability. The terminal management at the business level. So this is performance. We saw down below about the measurement. This is about the performance of loading trucks and capturing arrivals of rail cars and ships and so on for loading and tracking fiscal measurements, quantities, and reports, as well as integration into such as SAP. Other areas of performance, including the overall analysis, the overall graphics from the Forge platform, which you can hear about here in VTECH 2020. Asset performance management, APM, that I talked about a little bit before, as well as alarm management and managing safe operating windows within the refinery, and managing operator logbook and capturing experience and information, and the use of the same platform for training operators in the knowledge of the refinery dynamics, but also for use by engineers to do some offline views of unit behaviors using the dynamic simulation. The capability to configure system really anytime, the on-process migration capability of Honeywell, the on-the-fly configuration is still unique across a multi-system namespace managed by distributed server architecture. These are all elements that enable the better performance of the site. And lastly, in the top left, two key elements with respect to managing collaboration, sometimes perhaps across multiple sites by remote collaboration station, or managing emergency situations through our emergency console management in Experion. And lastly, Experion forms the basis for connecting the refinery remotely to a remote support, whether on-site or geographically distant, for specific performance of process units and assets. And we'll see in the coming slides what that looks like. If we take a look here at a functional view, if you want, of what Honeywell's activity is and how the refining knowledge, the deep refining knowledge comes into play for providing performance for refineries, we have this particular view, beginning with we start from the top, the integration into SAP, which is critical for most businesses, of course, for which Honeywell has done a number of different deliveries, integrating from multiple different functions, from production, from maintenance, from terminals, from offsites, for example. And as well then production planning through LP management of refineries, the ability to provide overall models for shutdown planning, for optimization of seasonal variations in refinery production, for example, along with managing production on a day-to-day, month-to-month basis, providing the necessary reconciliation of data across the sites in a consistent way without thousands of spreadsheets that some other people use. And then managing operations, the hour-to-hour, minute-to-minute interactions of operators with the plant. As I mentioned earlier, providing logbook and experience capture and so on. And of course, to the optimization and algorithm-focused ability to coordinate control across different units, along with the base control and safety. But that again then gets complemented, if you want, by process and operational data, focusing on operating capability and KPIs, and then overall engineering surveillance, which you can see here through the Forge platform, providing what I call, as I said earlier, process and asset surveillance or effectiveness in the site, and all that's really driven by a common end user experience overall on the site. Following this functional view, we can have a look at how things look when we are now able to provide connectivity to remote supports for refineries. So we've seen that overall refinery success is dependent on managing both capability and performance, and that performance itself depends on both connectedness and deep refining knowledge. Here, the Honeywell Forge platform, Forge for Industrial, of which you can see much more elsewhere in VTECH 2020, gives you here some example of remote connectedness and therefore performance management at its best in the latest generation of Honeywell technology, providing the ability to do many of these functions either site-hosted or remotely hosted, whether site delivered or remotely delivered. Some examples could include, for example, process performance. Now we have both our sister company UOP for their process units, and we have other licensors such as Woods for a delayed coker, providing remote support on our Forge platform for different process licenses that they have in the field. The same platform being usable for asset performance management here in the top right. As I said earlier, not only can we control rotating machinery, for example, at the base level in the controls, but we can also track their performance at the upper level, along with many other assets in the site. And that same platform provides the basis for enterprise-wide collaboration and KPIs and dashboarding, and that can be for multiple different functions, for process safety, for cybersecurity, asset performance, as I mentioned, as well as production performance, the actual reconciled results of the refinery on a day-to-day basis. And then ties into workforce skills and safety overall, and providing a platform for that collaboration to come through from everything from intelligent wearables to dashboards to tablets carried in the plants by operators and engineers as well. And here on this slide, we expand on the theme of remote connectedness by the latest capability in Honeywell is really to provide a very real remote operations support for business continuity in refineries and chemical plants across multiple facilities, as you can see in the bottom left. Having been driven in very recent times by the happenings of COVID-19 and the requirement to have a backup or other capabilities to control sites in the context of no access or little access to sites by people, for example. And these have driven a number of different initiatives in Honeywell to really focus on remote operations for control. And we have a number of customers looking at this at the same time, and these could end up, covering multiple different functionalities, multiple different functions that customers may require to be performed remotely, whether from engineering or whether from operations directly. So to summarize, we've looked at the refinery of the future and what it can focus on, how it can evolve. We've looked at aspects of petrochemical integration, as affecting the asset base and the potential yield patterns for refineries in the future as they focus perhaps less on fuels and more on the petrochemical molecules. But much more in the rest of the presentation, we focused on this idea of connectedness and the flexibility of the refinery, both requiring to be addressed. And we looked at how Honeywell, through managing both capability and performance in refineries, are able to then use the connectedness to provide these added benefits to refiners into the future for their own successful operation.